Warm greetings to all the viewers. Myself Hasit Trivedi along with my partner Sanjay Parmar will present this project. The topic of our project is Smart Door System to prevent COVID-19 transmission. This project we have prepared under the guidance of Dr. Sachin Gajjar sir.
So this is the presentation outline. The world is witnessing the big calamity in the form of COVID-19 and it has affected the major part of the world with its different strains. It has puzzled even scientists to get the exact solution to stop this spread. However, it is not possible to stay in the lockdown for a long time as it is not an practical approach. So the government has started offices, schools, colleges, malls and other public places with proper guidelines including wearing a mask and having normal body temperature as the mandatory condition for going anywhere. Thus, automatic door systems are becoming essential at public places to provide utmost safety in quarantine condition to avoid contacts and prevent the spreading of virus. Now, coming to the motivation behind selecting this topic. Nowadays, wherever we go, be it cafe, restaurants, office, school, college, any public place, we can observe a person holding a temperature gun to measure the temperature of the person entering a space. A separate way of obtaining body temperature using temperature gun is prevalent at entrance of public places. However, it requires additional human resource and hence there is high chance that the person who is measuring the temperature might get infected as well. Conventional security systems have been widely used, but contactless and automatic systems are paramount. Looking at the context of current pandemic situation, an automatic system which replaces all the manual efforts in evaluating the temperature and collecting the data will be of great use in our country. Automatic door systems offer several advantages in addition to reducing the chance of transmission of virus. Also, they provide agility, great operability and best hygiene condition. The main objective of this project is to design a smart door system to prevent COVID-19 transmission to guarantee a safe living environment at different places to a greater extent. The proposed system ensures safety measures and identifies the potential symptom before entering any public place. The automated system will stop the person with high body temperature from entering any public places. The proposed system is completely autonomous and contactless. The ideal approach to limit the transmission of COVID-19 and other viruses at commercial and public places can be done using the contactless door operation with appropriate medical safety check. The methodology can be divided into the following steps. This is the system outline of our proposed system. Here, Arduino UNO board is the heart of our system. It is connected to all the sensors and actuators and it processes the logic. Here, motion detector sensor is used to check the presence of a person in the vicinity of the checkpoint. An infrared temperature sensor is used to record the body temperature of an individual entering a space. LED and buzzer are used as a part of alert system and servo motor is used for the door automation purpose. Here LCD display is used to display the welcome message and the alert message according to the condition, and I2C module to reduce the pin utilization. Here is the hardware description of our project. We have used Arduino UNO board for system development purpose. Arduino is an open source single chip microcontroller of Atmel family. It allows the system to connect with the computer via a USB cable. It has 14 digital input-output pins, out of which 6 can be used as a PWM outputs. It has 6 analog input pins. It uses a voltage regulator to convert the input voltage to 5 volts. Here in the proposed system, Arduino takes signal from different sensors and processes them according to the set logic algorithm. The next component which we have used is passive infrared sensor. We have used it for the motion detection purpose. PIR sensor measures infrared lights emitting from any object in its area of view. PIR sensors are used in automatic lighting, security alarms and different applications. The output of PIR goes high when the object enters in the sensing range and automatically returns to low when an object leaves. It can detect up to 7 meters with an angle of 120 degrees. Due to its high precision result, it has been used for human activity detection purpose. The next and the very crucial component of our system is infrared thermometry sensor module. The MLX90614 is an IR thermometer for high precision contactless temperature estimation. It calculates temperature of an object by measuring the amount of infrared radiation emitted from it. It has an object temperature range of 70 degree to 380 degree centigrades, while it can record ambient temperature in the range of 40 degree centigrade to 125 degree centigrade with an accuracy of 0.02 centigrades. It can be used with any controller board that can communicate it with via I2C protocol. The next component which we have used is the Tower Pro MG90S servo motor. It is a rotation servo motor with metal gear and dual bearing support. It has rotation range of 180 degrees. It can receive and process PWM signals faster and better. Thus, in the proposed system, it is used for the door automation process. The next component which we have used is LCD with I2C module interfacing. Liquid crystal display LCD is an optical device that uses the light modulating characteristic of liquid crystals. LCD use backlight to produce images in color rather than emitting light directly. We have used LCD 20x4 which provides a cost-effective and straightforward solution with white colored characters to display. The inter-integrated circuits I2C protocols overcomes the drawback of LCD which consumes around 8 pins on the Arduino board, and I2C protocol reduces the pin utilization. However, using an I2C adapter directly soldered onto the pins of the display can save the pin utilization. It is a type of serial bus which uses two bidirectional lines called SDA serial data line and SCL serial clock line. Here, in the proposed system, LCD is used for displaying temperature and the welcome message and the alert message. The next component which we have used is a buzzer. We have used buzzer for our alert system. A buzzer is a voice device that converts audio modules into the sound signals. The last component which we have used is a breadboard. We have used it for easy component placing. This is the circuit diagram which we have created in the Proteus design suite. Here are some softwares which we have explored during this course of project. The first software which we explored is Arduino IDE. Arduino IDE is an open source electronic platform based on easy to use hardware and software. The Arduino IDE is a cross-platform application for different operating systems such as Windows, Mac OS and Linux. It is used to write and upload programs to Arduino compatible boards. Arduino uses its own programming language which is similar to C++. However, it is possible to use Arduino with Python or another high-level programming languages. In fact, platforms like Arduino work well with Python, especially for applications that require integration with sensors and other physical devices. The another software which we used is the Proteus design suite. We use this software for the designing and simulation of our system. It is an established software tool which is used for electronic design automation, and electronics engineers primarily use this software to create schematics and electronic prints for fabricating PCBs. Another simulation tool which we explored is the Walkve simulator. Walkve is an open source simulator for Arduino boards. It is used to learn Arduino programming, prototype ideas and share projects with other makers. It is one of the alternatives to the Tinkercad and Proteus simulator. Walkve in general provide convenient way to test logics and to create and simulate innovative projects. With availability of various libraries, it becomes very easy for beginner to learn and explore Arduino programming in Walkve simulator. This slide shows the design logic of our system. On the left side of the screen, you can see the flowchart of our system. First of all, system carries out the motion detection operation. If the human is detected, then the body temperature of that human is measured. If the measured temperature is less than the threshold value, Then system will display a welcome message and servo motor will rotate 90 degree in anti-clockwise direction to open the door. After the delay of 5 seconds, servo motor will automatically get closed by rotating 90 degree in the clockwise direction. If the measured body temperature of the person is greater than the threshold value, then the alert system starts. LED blinks and buzzer buzzes to alert the person. And this shows the hypothermic condition and door won't get opened. On the right hand side of the screen, you can observe a snapshot of the main program of our code, which functions and controls the whole automation of the system. This is the bill of materials, which includes pricing of each and every component used in our proposed system, and along with that it also shows the total estimated price of our prototype.
Code and the software simulation for our proposed system. So here we have included some libraries for the Arduino supports. So basically these libraries are a collection of codes that makes our job easier to interface or connect any sensors or modules with the Arduino board. So after that we have defined different pins of the servers along to the pins of the Arduino. And different pins of Arduino board with the different pins of the sensor that were like DSV sensor, the buzzer, the PIR sensor. After that we started our serial communication by giving the baud rate as 9600. Then we provided pin modes to the different pins, initialized the LCD and turn on its backlight. Then coming to the main operation of our system, like first of all the PIR sensor will detect the object detection. If the human is detected, then it will trigger the motion as one, that it will give the high signal, and the human detected will be print, and after that it will jump to the door function. And now in the door function, first of all the temperature of the object that is human would be measured, it will get printed. Now we have three conditions. The first condition is check that the sensor is working properly. So there might be some case that there is some false detection or some false result of the PIR sensor due to some reasons. So in that condition, if any object that is not a human but human is detected by sensor, then using this condition we can resolve that situation. Like we know that the minimum temperature of any human is 31, so there can't be the temperature that is lesser than 31 for any normal human. So if it's so that, like in that condition, we can identify that the human is not detected, and if we pass that condition, then in that case the human is detected, and the normal range for human is between 32 to 38 degrees centigrade. And in that condition it will print simple welcome message, and after that the door will open, and after the delay of 3 seconds door will get closed. And if the body temperature of human is greater than 38 degrees centigrade, then it is not a normal condition. It will print the alert message. The buzzer will get buzzed and door won't get open. The simulation of our proposed system. So now I will run the simulation of our system, and after simulating I will trigger this motion sensor and indicate that the human is detected. And since the temperature of that human is greater than 38 degrees centigrade, it will print the message that alert, go back home, and the buzzer is blinking, buzzing right now. If the temperature of the human is greater than 38 degrees centigrade, it will print the alert message and indicate him to go home. Now I will change the temperature of the human by setting here between normal range, that is between 32 to 38 degrees centigrade. And now I will once again trigger the PIR sensor. And since the temperature of the human is in the normal range, the door get opened, and after the delay of 3 seconds, door will get closed, as you can see here right now, and it will print a welcome message. So this is how our system will work.
Along with the proposed system, we can integrate further subsystems such as contactless sanitization system, automatic data collection system, face mask detection system, and health monitoring system. In contactless sanitization system, upon the opening of the door, the person can get sanitized by setting the sanitizer on the top of the door, which can be get triggered for a duration when the door is opened and person gets entered. Thus, the system will get an add-on contactless sanitization operation. In automatic data collection system, with the help of RFID card, so for example at schools and offices, the data of the person entering a place can be stored along with their body temperature details. This data can be uploaded to the cloud via using Python libraries, which can be further utilized for further analysis purpose and using the data in a meaningful way. In face mask detection system, TensorFlow based deep learning neural network can be implemented to detect the face mask. For image recognition, the OpenCV library can be used, and this system will ensure that the door will only get open if person is having normothermic condition as well as is wearing a mask. In health monitoring system, using some more sensors, we can measure and monitor heartbeats, oxygen percentage, and many more primary medical requirements, which can also help find out the possible COVID infected person. In this project, we have proposed, designed and implemented an automated system for early symptom identification before entering a public place that prevents the spread of the virus using the contactless temperature detection. The proposed system is implemented in a hardware model using Arduino UNO Board and is simulated in the Walkwe simulator. This system can be set up at any mall, workspace, school, college or any public entrance without the need of additional human resources. These systems ensures that no person with potential COVID-19 symptoms enter any place. The whole system is fully contactless and automated to stop the spreading the virus and eliminate the workforce requirement. The proposed design is cost-effective due to its simplistic arrangement, readily available low-priced components, and minimal production and assembly line. This product will benefit savvy users and can also be utilized for supervised entry to offices, shopping malls, hotels, and other public places where there is high threat of transmission. Here are some references which we have referred while preparing our project. These references include some journal papers, conference papers and websites.